Next one, bounded below sequence. A sequence AN is said to be bounded below if there exists a real number k such that AN greater than or equal to k. For all n belongs to n, then k is called lower bound of the sequence. Okay, that means if for every term which is must be greater than or equal to a real number, suppose if for every term in the given sequence which is must be greater than or equal to a real number, so then we will say that that sequence is called as bounded below sequence and that real number is called as lower bound of the sequence. For example, suppose if you have a sequence like this, AN is equal to 1, 2, 3, 4, 5. Same example. Okay. If you observe that in these sequences, 2 must be greater than or equal to 1, 3 must be greater than or equal to 1, 4 must be greater than or equal to 1, 5 must be greater than or equal to 1. That means for every term must be greater than or equal to 1. So we can say that this sequence is called as bounded below sequence and that number, that is 1, is called as lower bound of the sequence. Okay, bounded below sequence is nothing but for every term must be greater than or equal to some real number. So then in this case we can say that the sequence is called as bounded below sequence and that real number is called as lower bound of the sequence. So now let us see second example. One, 2, 3, 4, 5, so on up to infinite values. So in this example, all the terms except one, which is must be greater or equal to 1, all the terms, that means 2, 3, 4, 5, 6, all the terms which are 2, 3, 4, 5, 6, so on, all the terms except one must be greater than or equal to 1. So we can say that lower bound of this sequence, will be equal to 1 because all the terms must be greater than or equal to 1. Clear? Next, bounded sequence. If suppose the given sequence is both bounded above and bounded below, then such type of sequence is called bounded sequence. Okay, so mathematically this can be defined by a sequence AN is bounded if there exist two real numbers small k and capital K such that k less than or equal to AN less than or equal to k for every n belongs to n. So here small k is called as lower bound of the sequence, capital K is called as upper bound of the sequences. So now let us see one example for bounded sequences. For example, suppose if you have a sequence like this 1, 2, 3, 4. Okay. So now we want to find upper bound of these sequences, lower bound of these sequences. If we observe that here the number 1 is less than or equal to 4, the number 2 less than or equal to 4, the number 3 less than or equal to 4, the number 4 less than or equal to 4. That means if we observe that for every term in the sequence must be less than or equal to 4. So we can say that this sequence is called bounded above sequence, and that number is called upper bound. So in the sequences, upper bound is, so what is the upper bound in the sequences? Upper bound is 4, because for every term in the sequences must be less than or equal to 4. Okay. Similarly, lower bound of these sequences. So here in the sequences, 2 less than or equal to 1, 3 or 1 greater or equal to 1 greater or equal to 3, 1 greater or equal to 4. Okay. That means in the sequences every term except to 1 which is must be greater or equal to 1. That means all the terms in the sequences must be greater or equal to 1. So we can say that this sequence is called bounded below sequence, and lower bound of these sequences will be 1, because for every term in the sequences must be greater or equal to 1. Okay, so this type of sequence is called bounded sequences. So finally we can say that this sequence is bounded sequence. Suppose a sequence is not bounded, then such type of sequence is called unbounded sequences. Unbounded sequence is nothing but a sequence which is not bounded is called as unbounded sequence. Unbounded sequence is nothing but if at least one of either upper bound or lower bound does not exist in the sequence, then such type of sequence is called unbounded sequence. Unbounded sequence is nothing but at least one of either lower bound or upper bound does not exist in the sequence, then such type of sequence is called unbounded sequence. For example, suppose if you have sequence like this 1, 2, 3, so on up to infinite values. Already we know that lower bound of this sequence will be equal to 1. So in this case upper bound does not exist. Okay, LB means lower bound, UB means upper bound. Upper bound does not exist because there is no term which is must be greater or equal to all the terms in the sequences. That's why upper bound does not exist. So this sequence is called unbounded sequences. Unbounded sequence. Unbounded sequence is nothing but at least one of either lower bound or upper bound does not exist. Okay, so this is the example for unbounded sequence. Unbounded sequence is nothing but a sequence which is not bounded. That's all. Now we are going to discuss about some problems. For example, find general term of the sequence like this: 2, 3 by 8, 4 by 27, 5 by 64, so on. Find general term of the sequence 2, 3 by 8, 4 by 27, 5 by 64, so on. So now let us see how to find general term of the given equation. Now let us see how to find general term of the given sequence. Okay. So here we have a1. a1 is nothing but first term. So a1 which is equal to 2. a2 is equal to 3 by 8. a3 is equal to 4 by 27. a4 is equal to 5 by 64. So now we want to find general term of the given sequence. That means an is equal to what? If you observe this sequence, so then we have denominators of the terms are all perfect cubes, which are 1, 2, 3, 4, so on. 1 cube is nothing but 1, 2 cube is nothing but 8, 3 cube is nothing but 27, 4 cube is nothing but 64. And numerators are all one more than base of the cubes of the denominator. Suppose, so here we have a1 is equal to 2. a1 is equal to 2. 2 can be written as 2 by 1. So 2 by 1 can be written as 1 plus 1 by 1. 1 plus 1 can be written as 1 plus 1 by 1 cube. Similarly, let us take a2 which is equal to 3 by 8. 3 by 8 can be written as 3 by 2 cube, which is equal to 3 by 2 cube can be written as 2 plus 1 by 2 cube. Similarly, a3 which is equal to 4 by 27. 4 by 27 can be written as 4 by 3 cube, which is equal to 4 by 3 cube can be written as 3 plus 1 by 3 cube. Similarly, a4 which is equal to 5 by 64. 5 by 64 can be written as 5 by 4 cube. 5 can be written as 4 plus 1 by 4 cube. If you observe that this pattern, so then we have nth term will be equal to n plus 1 by n cube. Okay, so this is the general term of the given sequence. Similarly, let us see another example. Find the general term of the sequence. Three, 8, 13, 18, 23, so on. So now we want to find general term of these sequences. Here the given sequence is a arithmetic sequence because difference between any two numbers is 5. Difference between any two numbers is 5. 13 minus 8, 5. 23 minus 18, 5. 8 minus 3, 5. That means D is equal to 5. And also we have first term A is equal to 3. Okay. So here the given sequence is a arithmetic sequence with A is equal to 3, D is equal to 5. So then already we know that general term of the or nth term of the arithmetic sequences. Already we know that nth term of the arithmetic sequence which is equal to A plus n minus 1 into D. So which is equal to A is nothing but 3 plus n minus 1 into 5 is nothing but 3 plus 5n minus 5 which is equal to 5n minus 2. 5n minus 2. So this is the general term of the given sequence. So now I will give you some problems. Please try to solve those problems and maintain separate book for calculus. Okay. Please note the problems. Okay. Find the general term or nth term of the following sequences. First one, 1, comma, 5, comma, 9, comma, 13, comma, 17, so on. Second one, 1, comma, minus 1 by 4, comma, 1 by 9, comma, minus 1 by 16, comma, 1 by 25, so on. Third one, minus 1 by 5, 3 by 8, minus 5 by 11, 7 by 14, minus 9 by 17, so on. Next, fourth one, 3, 12, 48, 192. Next, find the upper bound and lower bound of the following sequences. First one, 2, comma, 1.9, comma, 1.8, comma, 1.7, so on. Next, second one, the sequence n square, where n is natural number. Third one, the sequence which is 1 plus minus 1 whole power n, where n belongs to capital N. Fourth one, sin n pi by 2 plus minus 1 whole power n by n. Okay, please try to solve these problems. Okay, very easy, no problem. Okay.